Hello, and welcome to the AP Calculus test preparation session sponsored by the Rice Center for College Readiness, where they're creating opportunities and raising expectations. My name is Keith DeRosier. I'm the Director of Mathematics at the Yes Prep Public Schools here in Houston, Texas, and I am a proud calculus teacher. I'm really excited to work with you all today and to hopefully see you during office hours on Saturday, April 18th. Let's take a look at the agenda for today. We've got a couple of things that we're going to focus on in the beginning that are specific to our current situation with the AP exam. We'll talk about some changes that have been made to the AP exam in light of everything happening with the coronavirus and schools being closed. We'll look at some specific supports that the College Board is putting into place to make sure that you are set up for success. There is then a handout that has several essential calculus skills that I want you to spend some time reviewing. We'll do a quick multiple choice. A quick true-false quiz after that. And then we're going to spend the rest of the time looking at several free response questions. Parts of the video I had pre-recorded for my own calculus students, and I'm using those questions here. And then I'm embedding different elements for you all specific to this review session. And then we'll end our time together by looking at support that I can offer beyond this session, as well as what's being offered by the College Board. Okay, so let's start by talking about changes to the AP exam. These are one-time changes that the College Board has put into effect in light of everything that's happening with the coronavirus. There are changes to the content of the exam. There are changes to the format of the exam. There's changes to the calculator expectations and also changes to the dates. So let's start by talking about the content. This year, the Calculus AB exam is not going to assess what we call Unit 8, which is Applications of Integration. Now, specifically, this unit includes concepts like the average value of a function, accumulation functions, area between curves, volume of revolution, and volume with cross sections. Depending on the calendar that your AP Calculus teacher has been following, you may or may not have studied some of these concepts. Okay. Additionally, there are significant changes to the format of the exam. The AP exam is normally a little over 3 hours long. You spend 105 minutes on multiple choice questions, followed by 90 minutes with free response questions. Each of those are a combination of calculator active and calculator inactive. This year, vastly different experience for you. First of all, you are likely going to take the exam at home. This is something that the College Board has never done before. You might be taking that exam using your laptop or on a cell phone. You're going to be allowed to use a textbook and notes. So my strong advice to you is make sure that you start preparing in advance. You don't need to worry about memorizing certain concepts, but you do have to make sure that you are proficient and comfortable. And I would encourage you spending some time pulling together important formulas, important concepts. Many of those are in the handout that I've provided for you. Let's see, additional things. Because you're going to be taking this exam online, you can either handwrite your responses and then take a picture and upload it directly, or you can type your answers in on the computer. Now, given the amount of mathematical notation and how difficult that can be to type, the expectation is that most math students will elect to work through the problems by hand and then take a picture. Let's see, what else? Also this year, if you are a Calculus BC student, there is no Calculus AB subscore. If you are enrolled in Calculus AB, don't worry about what I just said. That only applies to the Calculus BC students. Let's see, in terms of the graphing calculator, there have been in the past questions that are calculator active and you really absolutely needed a calculator for those. This year, you're allowed to have a calculator out and use the calculator, but the questions are being set up in such a way that the calculator is not really going to be that important. So you can use a calculator for the whole exam, but you're going to discover that you probably don't actually need it. Finally, the dates of the exam have changed. You have two options. The first administration will be Tuesday, May 12th at 1 p.m. Central Standard Time. That is the date that the College Board expects the vast majority of students will be taking the test. Now, if you run into some sort of a situation, if you lose power, something happens with your laptop, there is another test date available. That's that's going to be Monday, June 1st at 3 p.m. You definitely want to focus on the Tuesday, May 12th at 1 p.m. option though. We're going to go over to the College Board website to look at some more specific information on the exam. We're going to look at a site that has been put together by the College Board specifically for what's going on this year with the coronavirus. The website, the full website is available up here at the top, so pause the video and write that down if you need to. But we're just going to do a quick skim. You'll see at the very top the start times for all of the AP exams for Calc AB and BC. Here we are, Tuesday, May 12th. If you're taking it Central Time, 1 p.m. Okay, you already know that information. If you scroll down further, then you can find the math and computer science. Because this is a session focused on Calculus AB, we're going to click on that link where again you'll find the test information. You'll find the information on the timing of the exam. The exam has a 25-minute question, that's question number 1, with then 5 minutes to upload the response, followed by 15 minutes for you to work on question number 2, and then 5 minutes to upload that response as well. You can see the weight of each question, the question description. Each of the questions will assess student knowledge and skills developed in 2 or more of the eligible units. Here we see information that the units eligible for the exam, it's units 1 through 7. If you are a calculus student, you probably don't necessarily know what units 1 through 7 really are, but you can do some searching around on the College Board website and find out more specifically. Unit 8 is not being assessed. And then here is the makeup information, the makeup date information. If you are also enrolled in Calculus BC, you can click on Calc BC and you'll find that the composition of the test questions is the same, the weighting of the questions is the same, the units being assessed is different because of course the Calculus BC students, there's more content that you are exposed to, but everything else is pretty much the same, including the makeup test date. For those of you that are enrolled in multiple AP courses, you can find all the information that you need here for AP Science, AP World Languages, everything you need. So spend some time here if you need to. Let's talk about the support that the College Board is offering to make sure that students are set up for success. You know, depending on your school environment, depending on your calculus teacher, you might be in a place where you are receiving direct instruction from them remotely. That's great, but because not all students are in that situation, the College Board is actually doing live sessions that are available on YouTube. These are being facilitated by master calculus teachers. And these are happening every single day. I'll take you over to the website and show you where that information lives. Once they finish teaching the current content, they actually have a few days dedicated to review content. So you'll go back to earlier concepts like limits, derivatives, integrals, things like that. And the College Board is trying to push out in advance additional practice materials that you can use as you get ready for this unique testing experience this year. Okay, we're going to the College Board website to show you where the information on the live sessions can be found. Different site that the College Board has put together, the full address is up here at the top. So pause the video if necessary and jot that information down. Once you've done so, let's keep going. And if you scroll down a little bit further, what you'll see is the daily schedule. All of these times are Eastern, and they are doing live stream calls from 9 to 9:45 p.m. Eastern time every day for Calculus BC. If you look down a little bit further, live stream session 3 for Calc AB, that's every day from 2 to 2:45 Eastern time. Because this is mostly a Calculus AB, we're going to click on this link in just a second. But if you're in AP Art History, if you're in AP Physics, AP US History, there are live sessions being offered for all of those courses as well, and I would strongly recommend you spend some time watching those videos. The College Board has hired very experienced AP teachers to facilitate those sessions. So if we go to Calculus AB, we will see all the different videos that have been recorded so far. You can play all of them. You can subscribe to the channel if you would like. Everything that you need is going to be found here. And so I would definitely encourage you to spend some time doing that. Okay, so now let's take a look at what I've put together for you all in this handout. There are 3 sections that we're going to look at right now. Section 1 involves all the derivative rules that I want to make sure that you are very, very familiar with. Remember, you don't need to worry about memorizing them. Hopefully you've been exposed to all of them at this point, but all the derivative rules appear on pages 2 and 3. All the integration formulas that you're going to need appear on page 4, and then pretty much all the other key ideas are on pages 5 through 7. And when I say all the other key ideas, I'm talking about things like the intermediate value theorem, the mean value theorem, Riemann sums, the extreme value theorem, all those concepts, all those big ideas that you've been studying this year. My goal was to pull together pretty much all the things you need in order to be successful into this one place. Now, there are definitely some things that did not make it into the handout. This is still sort of in draft mode, but this should be a really good starting point for you as you start to pull together your own review materials. What I want you to do right now is I want you to pause the video and take as much time as you need to review the key information in pages 2 through 7. When we come back, we're going to do a quick sort of true-false quiz. That should be about 10 questions that I'm going to pose to you, give you a little bit of time, and then you're going to decide if the statement is true or false, and then you'll get some feedback. I have selected about 10 questions, 10 mathematical statements. These are all from a gentleman by the name of the Master Math Mentor. He has done some incredible work providing materials for teachers and students. And this is his work that I'm sharing with you right now. We're going to look at about 10 statements. I'm going to give you some time on the screen for you to then decide if the statement is true or false, and then we'll look at what the correct answer is and the supporting work. So that you have enough time, what I'm going to ask you to do is after each question, you hit pause. Once you think you have the correct answer, then you're going to hit play again, and we'll move into the solutions. So here we go. Number 1, you're only going to be given about 15 seconds for this. The first statement says, if f of x equals x squared minus 2x, then f prime of x is equal to the limit as x approaches 0 of the quantity x plus h squared minus 2 times x plus h minus the quantity x squared minus 2x, all of that divided by h. This should take you about 15 seconds to determine if this is true or false. Okay, and the answer is false. Everything might look really good in the beginning, but the issue is this limit expression right here. The way we define our derivative, it should be f prime of x is the limit as h approaches 0 of this expression up here, not the limit as x approaches 0. So this is an example of a false statement. If you get that one correct, congratulations. Let's try another one. Statement number 2, the length of a rectangle is 6 inches and the width is 4 inches. If the length is decreasing by 1/2 an inch per second and the width is increasing by 1/2 inch per second, then the area is also increasing by 1 inch per second. Hit pause. Come on back when you're ready for the answer. Okay. If you start off with the expression area is length times width, and then you take a derivative with respect to time, you'll get that dA dt equals L times dW dt plus W times dL dt. If you then evaluate that expression at the given information, you're going to get 1 square inch per second. So this is an example of a false statement. The units are wrong. Now, while we're here, I want to say one more thing about the notation. I really don't like the way this expression is written. Here's what is good. dA dt equals L times dW dt plus W times dL dt. That's perfect. It's this equal sign over here that's a little bit of a problem, because this expression on the left is only equal to the expression on the right at the given time. So you really would want to start on like a separate line and include this new information. All right, here comes another question. Question number 5. F of x equals x cubed plus 3x squared has a relative maximum at x equals -2. You know what to do. Hit pause. When you're ready, come on back and hit play. Okay, this is an example of a true statement. If I was solving this, I'd start with f of x equals x cubed plus 3x squared. I'd find the derivative, and I would want to find where the derivative is equal to 0. I would then construct a number line test, and what I see is that at x equals -2, the derivative has changed from positive to negative. Since your derivative changes from positive to negative, your original function is changing from increasing to decreasing at x equals -2. Therefore, f does have a relative maximum at x equals -2. Or you could use what is known as the second derivative test, and that would be a great way to do this as well. You know the first derivative is equal to 0 at -2. If I evaluate the second derivative at -2, I get a negative value. The second derivative test says that if your first derivative is equal to 0 and your second derivative is negative at the same place, then that must mean that your function has a relative maximum. Let's try another one. Should take you about 40 seconds. Let big F be an antiderivative of sine of x. If big F of 0 is equal to -1, then what's the value of big F of pi? Hit pause, work on this for about 40 seconds, then hit play. Well, since f is an antiderivative of sine of x, we can go and we can find the antiderivative of sine of x, which is negative cosine of x. And then you can say, well, using the fundamental theorem of calculus, I know that the integral from 0 to pi of sine of x dx is equal to big F of pi minus big F of 0. Rewriting, I can say that big F of pi is big F of 0 plus the integral from 0 to pi of sine of x. Working that out, you're going to get a final answer of 1. So this statement is true. Okay, question number 10. The slope of the line tangent to y equals 1 over e to the 2x times the quantity x plus 2 at x equals -1 is -3e squared. This one should take you about 60 seconds. Hit pause. When you're ready, hit play. You can see here that this is a true statement. Remember, slope of the tangent line is another way to say derivative. So you would need to find the derivative of this expression. Likely you probably did a quotient rule because this is a fraction. And you're going to have to involve a product rule because you have multiplication happening in the denominator. and then evaluate at x equals -1. If you do all of that work correctly, you'll get -3e squared. So this is a true statement. Okay, we're only going to do about 2 more of these. Okay, number 11, the slope of the tangent line to x times natural log of y plus y times the natural log of x is equal to 2e at the point e comma e is 0. This one's a little bit tricky. This equation over here, you have the x's and the y's mixed in together on the same side. This is an example of something that we refer to as implicit differentiation. Hit pause, work on this for as long as you need to, and then come on back. Okay, you can see here the derivative of x times natural log of y. When I take the derivative with respect to x, I'm going to use a product rule, and that's going to be x times 1 over y. Since I took the derivative of natural log of y with respect to x, I need the dy dx expression, plus natural log of y times the derivative of x is 1, plus now I move on to find the derivative of y times the natural log of x with respect to x. That is another product rule. And the derivative of 2e is equal to 0. From here, I'm going to evaluate at the point e comma e and see what happens. When I solve for dy dx, I see that dy dx is equal to -1, not 0. So this is an example of a false statement. Oh, I definitely want you guys to try number 13. Number 13, the function f is continuous on the closed interval 0, 8 and has the values in the table shown here at the right. I want you to determine if the trapezoidal approximation for the integral from 8 to 0 of f of x with respect to x is equal to 25. This should take you about 60 seconds. Hit pause, work through the problem, then hit play when you're ready. Okay, probably the trickiest part in this problem is paying attention to your limits of integration. Your lower limit is 8, your upper limit is 0, and that's not normally the way that we would write a problem. We would normally think about doing an integral from 0 to 8. And you can make that switch of the limits of integration if you would like, but it is going to introduce a negative sign into your final answer. You'll have to take the final answer and multiply by a -1. So what you see here is the trapezoidal approximation of the integral from 0 to 8 of f of x. That calculation is equal to -25. Well, if the integral from 0 to 8 of f of x is with respect to x is -25, then if I switch the limits of integration, and I'm going to go from 8 to 0, then it must be the negative of -25, which is +25. So this is a true statement. Okay, number 14 asks to, using the table at the right, if h of x is equal to f of g of x, is h increasing at x equals -2? Is that a true statement or a false statement? I want you to take 60 seconds, work through the problem, hit pause while you do that, then hit play. All right, if you're told that h of x is f of g of x, or f with the composition of g of x, then that's a chain rule. So this first set of calculations that you see here is the chain rule. H prime is f prime of g of x times g prime of x. If I evaluate all those expressions at -2, that's what I'm seeing over here on the right. Use the table of values to determine the value of f prime of 2, f prime of -4. You get that h prime of -2 is -16. So since h prime of -2 is negative, that means that the function h is decreasing at x equals -2, not increasing. So this is an example of a false statement. All right, I think we're going to make this our last one. For the function f, f prime of x equals 5x plus 3, and f of -2 is equal to 4. The approximation for f of -2.1 using the tangent line approximation to the graph of f at x equals -2 is -7. This should only take you about 30 seconds. I want you to decide if this is true or false. Hit pause while you do the work. Hit play when you're ready. Okay. Well, if I'm going to do a tangent line approximation, first I need to write the equation of the tangent line. To do that, you need the slope of the tangent line. That's why they give you the derivative. So f prime of -2, when I evaluate this expression, I get -7. This -7 represents the slope of the graph at x equals -2. We're told initially that the value of the original function at -2 is 4. So putting those two things together, I can write the equation of the tangent line to be y equal -7x minus 10. Using that tangent line, I can approximate the value of f of -2.1 by plugging in -2.1 everywhere there's an x, and we get 4.7. So this is an example of a false statement. All right, this is truly going to be the last one. Question number 23. Find the limit as x approaches pi of tangent of x minus tangent of pi all over x minus pi. And according to what's shown here, that limit is equal to 0. I want you to decide if that is true or false. This should take you about 20 seconds. Hit pause, then hit play when you're ready. The limit as x approaches pi of tangent of x minus tangent of pi over x minus pi. Well, I'm going to do that by doing a direct substitution, and I get 0 over 0, which is the indeterminate form. Now, because you're getting an indeterminate form, what that really means is you want to apply L'Hopital's rule. L'Hopital's rule says that if this limit results in an indeterminate form, then if I take the derivative of the numerator, divide it by the derivative of the denominator, and take the limit as x approaches pi, whatever I get from that expression will have the same value. So the derivative of tangent of x is secant squared of x. Look that up on the handout if you need to. Tangent of pi, well, pi is a constant. Tangent of pi is a constant. The derivative is 0. The derivative of x is 1. So when I take the limit as x approaches pi of secant squared of x over 1, you get 1. This is a false statement. And that is the last problem. So now we're going to go back to the rest of the PowerPoint where we're going to talk more about free response. Through these free response questions. These can be found on, I believe it's the last 4 pages of the handout. And what I'm going to ask you to do with each of the problems is first, review the question on your own. That's going to take you about 2 minutes. While you're reviewing it, I want you to read through the problem. I want you to mark it up, identify any important information, any sort of problem attack skills your calculus teacher has taught you to do. You should use those. Then I want you to work through as much of the question as you can. Now, maybe you're a really strong calculus student, or that maybe this is a topic that you feel really good about, and you're able to work all the way through the problem on your own. That is fantastic. But maybe you're struggling with the concept and you need a little bit more support, and that's okay too. What I want you to do is spend at least 10 minutes on your own working through the problem. Then hit play, and you're going to then go through the video. You don't have to watch the entire video. Most of the clips are between 15 and 20 minutes. Just fast forward to the parts where you see me working through part A, if that's what you're struggling with, part B, part C, part D, or you can watch the entire video. That's totally your choice. But what I would encourage you to do is at the end of the problem, make a list of any key concepts that you know you need to review. So if part A involved, doing a tangent line approximation and you completely missed that one, then that should be a good indication for you that you are going to need some more support with those tangent line approximations. And so you should be actively looking for more practice problems. All right, let's do it. This first free response question that you are going to look at came from the 2019 A, B, and BC exams. This is question number 3. So this is a very recent question. It showed up on both exams. Now, the average for Calculus AB students out of 9 points was 2.70 points. For BC students, it was 4.66 points. Generally, BC students have a higher average on these common AB, BC questions. It doesn't mean that that's always the case. Now, the thing I want you to know is that the major skills being assessed involve relationships between a function and its derivative, properties of definite integrals, the fundamental theorem of calculus, absolute extrema on a closed interval, and techniques for evaluating limits. So those are the big 5 skills being assessed in this particular question. Now, it is also possible that one or more of the skills being modeled in this question won't actually be assessed when you take your exam later in May. That's okay. You're still enrolled in a Calculus 1 course. Many of you are going to go off to college and enroll in Calculus 2, and those professors are going to expect that you have a healthy understanding of the entire Calc 1 curriculum. So don't worry, it's possible these questions are over-preparing you. It is also, though, very likely that there will be some skills that it will be assessed on the exam that we're not talking about today. We only have about 70 to 80 minutes total, and that is a tall order to compress the entire calculus program into an 80-minute review session. We could be together all week. God, I wish we could do that. All right, so that's the background on the question. I want you to hit pause, work through the question, follow the instructions that I outlined on this slide back here. When you're ready, hit play, watch as much of the video as you need to, and then you are going to move through the video to the place where you see sample free response question 2 information on the screen. Good luck. All right, calculus friends, let's keep on rocking and rolling here. This is question number 3 from the 2019 BC exam. This is the first calculator inactive question that you would have seen. Okay, so we've got a graph. This is the graph of f, okay? The continuous function f is defined on the closed interval -6 less than or equal to x less than or equal to 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter circle, okay? Line segment, quarter circle. Got that. The quarter circle is centered at the point 5, 3. So there's the point 5, 3. It is known that the point 3, 3 minus the square root of 5 is on the graph of f. So this point right over here has coordinates of 3, 3 minus the square root of 5. Okay, let's see what's going on. In part A, if the integral from -6 to 5 of f of x dx is equal to 7, find the value of the integral from -6 to -2. Show the work that leads to your answer. Okay, so they're telling me that the area bounded between x equals -6 and x equals 5, the graph of f of x and the x-axis is equal to 7. Well, I can see the part of the graph from -2 to 5, but I can't see the part of the graph from, -6 to -2. So that's going to be a little bit tricky. Fortunately, they gave me some information. We know that the area from -6 to 5, the integral from -6 to 5 f of x dx is equal to 7. And they want me to find the area from -6 to -2. So my first thought is I know that with integrals, I can break this up into 2 different integrals. So consider this for a second. The integral from -6 to -2 of f of x, that's what I want to find out. When I add it to the integral from -2 to 5 of f of x dx, Well, that has to be the same as this integral from -6 to 5. So adding the two integrals together gives me a value of 7. Using some algebraic and geometry trickery, I can figure this part out using the graph. The integral from -2 to 5 just says I have to find the area from x equals -2 all the way to x equals 5. I can figure this out, and then I can say, well, the part that I don't know added to the part that I know is equal to 7, and I can subtract. So here's what I'm going to do. The integral from -6 to -2 of f of x. I don't know what that is, but we are going to take the time to figure out the area from -2 to 5. Starting at x equals -2, I have this triangle over here. Area is going to be base times height, cut that in half. That has an area of +1/2. This part of the triangle down here has an area of -1/2. Those guys cancel each other out. Okay, so those two cancel each other out. This little triangle below the x-axis has a height of 1. It looks to have a base of 1/2, and it's below the x-axis, so I'm going to say 1/2 times my base times my height. Keep in mind that's all negative. That gets me that area. The next part I'm interested in going from this point here to x equals 2. Now that is another triangle. It's above the x-axis, so 1/2. The base is going to be 1.5 or 3/2. The height is 1, 2, 3. So far, so good. I've calculated that area. What's left is this region underneath the semicircle. So all of this. Unfortunately, I cannot find that area directly. I'm going to have to get a little clever with this. So what I know is that I've got this square. And if I look at the area of the square, which is going to be 9, and I knock out the area of the quarter circle, it'll give me the area that I'm after. So I'm going to start with an area of 9, and I'm going to subtract from this the area of the quarter circle, 1/4 of pi. My radius is 3, so 3 squared. All this is the area from -2 to 5. When I add this area with the area from -6 to -2, I'm going to get 7. Well, we can clean this up a little bit if we want to. The integral from -6 to -2 plus, what do we have here? 1/2 times 1/2 is 1/4 times 1. I'm going to have a -1/4. 3/2 times 3 is 9/2 times 1/2 is 9/4. That's convenient. Plus 9 minus 1/4 of pi times 3 squared is 9 pi over 4. Okay, the integral from -6 to -2 of f of x with respect to x, plus inside here -1/4 plus 9/4, that's going to be 8/4. 8/4 is 2, plus 9 is 11, minus 9 pi over 4 is equal to 7. I want this part here, so I'm going to say then that the integral from -6 to -2 of f of x with respect to x is going to be 7 minus 11 minus 9 pi over 4. You can simplify if you want to. There's no need to. The simplified version is 9 pi over 4 minus 4. Let's look at what they did for points. This initial statement where you are replacing this one integral with these two very specific integrals gives you 1 point. Correctly determining the integral from -2 to 5, that was all of this work. Unsimplified or simplified was a second point. And then finally reaching here is your third point for a grand total of 3 points. I like that. It's a little tricky. There's some nice access points though. Simplifying is definitely not something I would encourage anybody to do. You're just running all sorts of risks and making mistakes. All right, let's keep moving. Part B. Evaluate the integral from 3 to 5 of 2 times f prime of x plus 4. The integral from 3 to 5 of 2 times f prime of x plus 4. Okay, well, I don't know that we're going to have any algebra trickery here. But what I do know is this. You want me to find the integral of 2 times f prime of x plus 4. I can use some integration properties to say that this is the same as the integral from 3 to 5 of 2 times f prime of x with respect to x, plus the integral from 3 to 5 of 4 with respect to x. I'm breaking this into two different integrals. I'm using the distributive property of integrals over addition. This 2 that I'm multiplying by is a constant that can get pulled outside. So now I have 2 times the integral from 3 to 5 of f prime of x dx plus the integral from 3 to 5 of 4. Now, you might say, well, gosh, what's going on over here? Couple of options. The integral of 4 is 4x, and you can evaluate from 3 to 5. Or you can keep in mind that y equals 4 is a horizontal line. So you're asking me to determine the area from 3 to 5 underneath the line y equals 4. Either way you do this, what you're going to do is if we do the integration, you're going to say that this is 4x, and you evaluate from 3 to 5. You plug in the 5, you get 4 times 5 minus 4 times 3, you're going to get 12, and you're going to get 8 for this little part over here. If you had looked at it as an area computation, here's the line y equals 4, here's x equals 3, here's x equals 5. I want to find the area of this rectangle. The length is 2, the height is 4, the area is 8. Works out no matter what. Let's look at this first integral though. How do I integrate f prime of x? Well, f prime is the derivative of f. I want to find the antiderivative of that. Well, the integral of f prime is just f of x. And I'm going to evaluate that from 3 to 5. Okay, we're getting a little messy here. We've got all of this plus, and that's why I think it was a really bad idea for me to do this work over on the side. I should have done that separately, sorry. Anyway, we have 2 times f of x, evaluate from 3 to 5, plus 8. So this is 2 times f of 5 minus 2 times f of 3 plus 8. F of 5, I can pick off from the graph, is 0. Plus f of 3. F of 3, the y value in x equals 3, we've determined, we were told, was this 3 minus the square root of 5. And then plus 8. I can stop here, or I could distribute and say this is 6 minus 2 square roots of 5 plus 8. I feel like I made a tiny mistake here somewhere. It was, oh, that's why. Sorry, friends. 2 times f of 5 minus 2 times f of 3. F of 5 is 0, so 2 times 0 minus 2 times f of 3. So this would be minus 6 plus 2 square roots of 5 plus 8. Simplify that, and that is going to be 2 plus 2 square roots of 5. All right, for this problem, what did the College Board do? They awarded 1 point for the fundamental theorem of calculus. That's in this step here where you recognize that the integral of f prime of x from 3 to 5 is the same as f of x. Being evaluated from 3 to 5, that was 1 point. And then for reaching your final answer, any of these, simplified or not, is the second point for a grand total of 2 points. Sorry, that one was a little messier than I had expected. See if I can do a better job with part C. Okay, part C. The function g is given by g of x is the integral from -2 to x of f of t dt. Find the absolute maximum value of g on the interval -2 to 5. So on the interval -2 to 5, what I want is the maximum or the absolute maximum value of g. Now, you guys are in a Calculus BC class. You should be comfortable with this process. And you know that in order to find the absolute maximum or the absolute minimum value of a function, the first thing we do is we look for a candidate. The candidate is going to be where g prime, if you're looking for an absolute max, you're looking for where g prime makes a change from positive to negative. That's in general what you would do. Well, how do we find g prime? G prime is the derivative of this integral from -2 to x of f of t dt. The derivative of the integral of a function from a constant to a variable. This is the second fundamental theorem of calculus. Derivative of the integral of a function from a constant to a variable is just the original function back again. So g prime is f. This is good news for us. We have the graph of f. If I want to know where g prime changes from positive to negative, I can say g prime changes positive to negative. Where does that change happen? Well, it happens over here at x equals -1. I can see that change at x equals -1. And I know that because f of x is equal to g prime changes positive to negative. That's my candidate. That doesn't mean that that is the location of the absolute max. It just tells me that's where I might have this happen. I'm also going to evaluate my endpoints. Well, the endpoints are x equals -2 and x equals 5. What we're going to have to do is we're going to have to evaluate g at -2, g at 5, and g at -1. We're going to be looking to see which of these three values is the greatest. Well, g of -2 means go to my function, and I'm going to evaluate that integral from -2 to -2, f of t dt. Well, the integral from -2 up to -2 has to be 0. To find g of 5, that's the integral from -2 to 5 of f of t dt. Well, wait a minute. The integral from -2 to 5, I think we actually did all of that work earlier. That was all the way back in part A. The integral from -2 to 5 was this computation, which was all this mess here. When we simplified it down, we got to 11 minus 9 pi over 4. There's no need to do that work again. We've done it once before, so use that result. G of 5 is 11 minus 9 pi over 4. And finally, we need to evaluate g of -1. Well, that is the integral from -2 to -1 of f of t dt. To do that, I'm going to look at my graph from -2 to -1. That's this little triangle here. The base is 1, the height is 1. The area is going to be 1/2 times the base times the height, which is 1/2. So now here's the part that's going to be a little bit tricky, is you've got 1, 2, 3 different values. Which of these is the absolute maximum value? Well, it's clearly not 0 because 1/2 is larger, But now you're going to have to go through the mental gymnastics here and kind of think about 9 pi over 4. Well, what do I know? I know that pi is a little bit bigger than 3, right? Pi is like 3.14, blah, blah, blah. A little bit bigger than 3 times 9 is what? A little bit bigger than 27. Maybe it's even bigger than 28. Divide that by 4, you're going to have some number that's maybe a little bit bigger than 7. 11 minus a number that is a little bit bigger than 7 is going to be greater than 3, which is greater than 1/2. So this must be the absolute maximum value. So the conclusion is the absolute max value of G on the interval, what's the interval that we're looking at? Where did it go? On the interval -2 to 5 is 11 minus 9 pi over 4. College Board awarded 3 points for this. First point came in with making the connection that G prime is equal to F. The second point comes in when you recognize that x equals -1 is a candidate. And then the third point comes in, they just call this answer with justification. That's all of this work that we did here. That third point is going to be a tough point to earn, but I think the first point and the second points were rather friendly ones that I would expect you guys to be highly successful with. All right, let's close out with part D. Okay, part D says find the limit as x approaches 1 of 10 to the x minus 3 times f prime of x over f of x minus arctan of x. Don't worry, this problem looks much, much worse than what it actually is. If I'm going to evaluate this limit, one of the first things I would encourage you to do always, always, always is try direct substitution. Maybe your teacher called it evaluation. You probably remember it as plug in. What happens with this function here if I evaluate it at 1? I'm going to get 10 to the first minus 3 times f prime of 1 over f of 1 minus arctan of 1. Now that may not make any sense yet, but let's keep cleaning this up. 10 to the first power is 10 minus 3 times f prime of 1. Remember, this is the graph of f. F prime means slope of the tangent line at 1. How am I going to find the slope of the tangent line? It's the same as the slope of the line that I'm on. The slope of the line, I can do rise and run. Rise 2, run 1. So that's going to be 2. F of 1 is the y value when x equals 1. Well, that's just 1. Arctan of 1, now that's a trickier one. Arctan of 1, you're asking yourself the question, tangent of what angle is equal to 1? Maybe you know that it's pi over 4. I would hope that you would. Arctan of 1 is pi over 4. This guy here is a perfectly acceptable final answer with no substitution needed. If you're like, whoa, where did pi over 4 come from? I'm not going to get into all of that right now. But what I want you to know is that arctan of 1 is some constant. And since it is some constant, you don't actually have to evaluate this. You don't have to say arctan of 1 is pi over 4. You could have just left your answer as 10 minus 3 times 2 over 1 minus arctan of 1. And you would have earned the same point as this kid who went and did all the evaluation. So leave it like this, leave it like this. This problem is only worth 1 point. For those of you that might have been thinking, but wait, I want to do L'Hopital. L'Hopital's rule does not apply here because you don't have a limit of the form 0 over 0. It's not an indeterminate form. So this is direct substitution. Get in, get out, and be happy with it. Congratulations. Okay, let's talk about sample free response question number 2. This problem also came from the 2019 AB and BC exams. This is question number 4. For AB students, the average is 1.81 points. That's a low scoring question, but it was also relatively low scoring for the BC students where their average was 3.56 points out of 9. The major skills being assessed here are related rates, instantaneous rate of change, and separable differential equations. The College Board over the last couple of years has gotten very, very good at writing these questions that incorporate multiple skills from multiple units of study. You really need to be on your toes and be ready. So just like you did before, follow the instructions of first read through the question on your own, mark it up, work through the problem for about 10 minutes. When you're ready, hit play and you can watch how I would have coached my students to work through the problem. When you're done, tally up how many points you believe you earned and then come back and see, is that better than the average AB student? Is it better than the average BC student? And, high five yourself if you're beating the average on this question. Okay, when you're ready, you're going to move forward to where you see sample free response question 3 show up on the screen. All right, here we go. This is question number 4 from the 2019 Calculus BC exam. That means that it's a calculator inactive question, so put that calculator away. You're not going to get a chance to use it. Here we go. A cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time t is modeled by dh dt equals -1 over 10 times the square root of h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with radius r and height h is V equals pi r squared h. All right, they just gave us a ton of information, so let's make sure we read that again. A cylindrical barrel with the diameter of 2 feet. Okay, so here's my cylinder. I know that the diameter is 2 feet, contains collected rainwater. That's going to be the shaded region here. The water drains out, so we're leaving through a valve at the bottom of the barrel. So you can imagine a little like drip, drip, drip happening down here. The rate of change of the height of the water in the barrel with respect to time t is modeled by this relationship dh dt equals -1 over 10 square root of h. So dh dt is -1 over 10 times the square root of h. Okay, and height is measured in feet, so the units here are going to be feet. T is measured in seconds, so feet per second. We know that the volume V of a cylinder with radius r and height h is V equals pi times r squared h. You didn't even need to know that. They gave it to you, but you could have figured that out. Area of a circle is pi r squared times the height h. Part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. I want rate of change of the volume with respect to time. That means dV dt when the height of the water is 4 feet. So H is 4 feet. I want to find dV dt when H is equal to 4. Well, let's think about that. I want to know dv dt when h equals 4. I know that for this problem, the volume is pi times the radius squared times the height. Okie dokie. And we've got this cylinder. Well, what do I know about this cylinder? It has a diameter is 2 feet. So that means that the radius has to be 1 foot. Or, yeah, 1 foot. Okay. So the volume in this case is pi times 1 squared times h, or volume equals pi times h. If I want to find dv dt when h equals 4, we're going to find the derivative with respect to t. Well, pi times h, pi is a constant, so the derivative is going to be that dv dt is equal to pi times dh dt. We know that dh dt is equal to negative 1 over 10 times the square root of h. If I want dv dt when the height is 4, I'm going to have to come over here and say, well, what is dh dt when h is 4? Well, I'm going to plug that in, negative 1 over 10 times the square root of 4. Easy enough. Square root of 4 is 2. Negative 1/10 times 2 is negative 2/10, or negative 1/5. So it must be that dv dt is pi times negative 1/5, or if you prefer, negative pi over 5. Now let's be careful with the units here. V is volume. Since the height is measured in feet, the radius is measured in feet. This is going to be cubic feet for the volume. T is time, and time is being measured in seconds. So this would tell me that dv dt when h is equal to 4 is negative pi over 5 cubic feet per second. What that would mean is that when the height is equal to 4 feet, when the height of the collected rainwater is 4 feet, the volume is changing. Well, specifically, it's decreasing at a rate of pi over 5 cubic feet per second. They didn't ask us to explain the meaning of the answer in this problem, but they could have, and we would have been ready for that. In terms of points, they awarded 1 point for your recognition that dv dt is pi times dh dt, and then the second point comes from your numerical answer with the appropriate units for a grand total of 2 points. Not too bad. That's part A. All right, let's look at part B. In part B, we're told when the height of the water is, sorry, blurry there, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? And we have to explain our answer. So when the height of the water is 3 feet, so h equals 3 feet, is the rate of change of the height of the water? Well, rate of change of height of the water means dh dt. Is the rate of change of the height of water with respect to time increasing or decreasing? What that means is I'm going to have to look at the derivative of dh dt at h equals 3 feet. I already have an expression for dh dt, but I need to find the derivative of this expression at h equals 3 to figure out the correct answer. So here we go. In part B, I want to find the derivative with respect to t of dh dt when h equals 3 feet. Now, keep in mind, we already have an expression for dh dt. dh dt is negative 1 over 10 times the square root of h. And I want to find the derivative with respect to t at h equals 3 feet. So you're going to want to be really careful here. We're taking the derivative with respect to t, but the variable over here is h. So, well, the negative 1 over 10 is a constant. The derivative of the square root of h, or h to the half, is 1 over 2 times the square root of the height. But you're taking the derivative of height with respect to t, so you have to multiply by dh dt. And then we're going to evaluate this expression at 3 feet. Okay, well, negative 1 over 10, not a big deal. H equals 3, I could plug in 3, fine. But what's dh dt? dh dt, remember, is that expression that we saw before. It's the negative 1 over 10 times the square root of h. And we're going to evaluate this whole thing at 3 feet. If I plug in 3 everywhere there's an h, we get negative 1 over 10 times 1 over 2 square roots of 3 times negative 1 over 10 times the square root of 3. Now, that is the derivative with respect to time of dh dt at h is equal to 3. The reason we did that is we wanted to know, is this rate of change increasing or decreasing? Well, look at your final answer. Negative 1 over 10 times a positive 1 over 2 square roots of 3 times negative 1 over 10 times a positive square root of 3 has to be positive. And so what that means is your derivative of dh dt is positive. Therefore, the rate of change of the height with respect to time is increasing at h equals 3 feet. We know that because your derivative is positive. We don't even need to know positive what, we just need to know positive. Let's look at how they awarded points. They awarded 1 point for correctly finding the derivative of the negative 1 over 10 square root of h and getting this part right here. So basically they're saying, if you know how to find that derivative, we're going to give you the point, even if you forgot to use the dh dt. However, if you use the dh dt, so if you made it to this point here, you remembered to apply the chain rule, they awarded a second point, and then your last point comes in here when you correctly evaluate the second derivative at 3, recognize that that's positive, and then give your final conclusion. That is your final point for a grand total of 3 points. Not bad. I would hope this is still going to be a relatively high scoring question, especially for Calculus BC students. Let's move into the final part. Here we go with part C. It says, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So at time t equals 0 seconds, the height of the water is 5 feet. So the height at time 0 is 5. They want me to use separation of variables. We should be really comfortable with this process. The name says it all. You're going to go to your differential equation, which has dh dt negative 1 over 10 square root of h. We're going to separate the variables. We're going to solve that differential equation by integrating both sides, using the initial condition, and wrapping it up from there. So, here we go. Part C. We know that dh dt is negative 1 over 10 times the square root of h. And we have an initial condition that h of 0 is equal to 5. So let's separate the variables. I'm going to multiply both sides by dt. dh is equal to negative 1 over 10 times the square root of h. times dt. If I've got dh on the left, I have to get the square root onto the left as well. So I'm going to divide both sides. Dh over the square root of h equals negative 1 over 10 dt. At this point, I've correctly separated the variables. So I'm going to integrate on the left. I'm going to integrate on the right. You might know right away what the integral of dh over the square root of h is. I'm going to assume that you don't. And so let's do this work on the side. The integral of dh over the square root of h, that's the same thing as saying dh over h to the half, which is the same as saying h to the negative 1/2 dh, right? Just rewrite it with a negative exponent. I have h to a power. The power rule says add 1 to the power. Negative 1/2 plus 1 is 1/2. Divide by that new power. 1 divided by 1/2 is 2. To integrate negative 1 over 10 dt, that should be even easier. The integral of negative 1 over 10 with respect to t is negative 1/10 t. Integral on the left, integral on the right. I'm going to set them equal to each other, but don't forget about your constant of integration. So 2h to the 1/2 equals negative 1/10 t plus c. I can tell you right now, you have already earned a lot of points with the work that you've done. Ultimately, you need to get your final answer expressed in terms of h equals, so h by itself. We have an initial condition. I'm going to use that initial condition right now. H of 0 is equal to 5. So when t is equal to 0, h is going to be equal to 5. So if I plug that in, I'm going to get 2 times the square root of 5, h to the half means square root, is equal to negative 1/10 times 0 plus c. So 2 times the square root of 5 is equal to c. Okay. So going back to the original equation, 2h to the half equals negative 1/10 plus our c, which is 2 square roots of 5. We're going to divide both sides by 2. H to the half means square root of h. Negative 1/10 t divided by 2 is the same as negative 1/10 t times a half, so that's negative 1/20th t. 2 square roots of 5 divided by 2 is square root of 5. To get h by itself, I'm going to square, and I'm going to square. Square root of h squared is h. On the right, I'm going to say negative 1 over 20t plus the square root of 5, the whole thing squared. I don't need to simplify. I don't need to expand. All of that would be a waste of time and possibly throwing away a point. Let's look at the points here. There was 1 point earned as soon as you separated the variables. And I'll tell you, this is a really important point. If you correctly separate the variables, you get the first point. If you do not correctly separate the variables, then you are done. There are no additional points that you could possibly earn. So this first step is a really important access point. I would put a star next to it and make sure that you are always doing that. Then they awarded 1 point for correctly finding the antiderivatives. You had to find both of them. Okay, the next point comes in for the work with the initial condition and your constant of integration. Finally, your last point involves saying what h is equal to. That is your last point. This is a 4-point question. This was the greatest number of points that we've seen for any of the questions on the test this year. Separation of variables is a really important concept for you to master. This could be as much as 5 points, or I've even seen a 6-point separation of variables question. You want to make sure that you are able to rock a question like this from start to finish. That's it. All right, so this is where I'm going to call the challenge by choice part of the review session. There are two different problems that I've selected for this last free response question, and it's totally your choice which one you want to work on. So let me tell you a little bit about the two questions, and then I want you to decide which one to do. Now, of course, if you're doing this at home and you decide you want to work through both problems, that's a great idea. That is showing your investment in being prepared for the AP exam in May. Strongly encourage that. The first question came from the 2018 AB and BC exams. Question number 3. Average score for an AB student is 3.36 points, so that's pretty good. For BC students, the average is 5.18 points. This problem assesses the fundamental theorem of calculus, the definition of a definite integral, and relationships between f prime, and f double prime. Before you start on that one, let me introduce you to question number 4. Question number 4 is from the 2018 AB and BC exams. Question number 4. Average for AB is 2.77 points. Average for BC is 4.43 points. Major skills being assessed here: instantaneous rate of change, mean value theorem, Riemann sums, and related rates. If you're looking for a challenge, I would encourage you to work through question number 4. This question is assessing some skills that have not been discussed in free response questions 1 and 2. If you're looking for something that will probably be a little bit more comfortable, you need an ego boost right now, then I would say go for sample free response question 3. Either one you select, it's totally up to you. You can do both. I am never going to know. When you're done, hit play, go through, score it up, give yourself a summary of what you need to review, and then you are going to proceed to what should be the final slide where we close out on today's session. All right, here we go. It's been a minute or two since I filmed my last calculus video, so I hope that all this comes back to me. This first question that we're going to look at, or this first question I'm going to film, is from the 2018 AP exam. It's question number 3. So if you were a calculus student in May 2018, this would have been your first calculator inactive question to work on. So here we go. We've got the graph of g given to us. It says the graph of the continuous function g, the derivative of the function f, is shown above. The function g is piecewise linear for -5 less than or equal to x less than 3, and g of x equals 2 times x minus 4 squared for 3 less than or equal to x less than or equal to 6. Okay, they just gave us a whole lot of information. Let's make sure we know what's going on. We've got the graph of g, and so I like to write g in a whole lot of places so that I don't mess this up. We can see that the graph is continuous. The derivative of the function f, so g is actually the derivative of f. That's what they said right here. That may be helpful later on. It probably will be, but I don't know yet. The function g is piecewise linear, so all of these pieces that we see are linear, except for this part over here, which is shaped like a parabola. Okay. In part A, they tell us that f of 1 is equal to 3, and to find f of -5. So f of 1 is 3, and I need to find f of -5. For those of you that are familiar with this, they gave me the value of the function at one point. They're asking me for the value of the function at another point. This is a classic fundamental theorem of calculus problem. The FTC says that the value of the function at -5 is equal to the value of the function at 1 plus the integral of the derivative of the function from 1 to -5. F of -5 equals f of 1 plus the integral from 1 to -5 of f prime of x dx. Now you might say, wait a second, hold on, how am I going to figure this out? There's a whole lot going on here. To find the integral from 1 to -5, that means find the area under the curve. but I'm going from +1 to -5. Those limits are in the wrong order. Well, that's something that we can fix. So I can write this as f of 1 minus the integral from -5 to 1 of f prime of x dx. I'm being asked to find the area from -5 to 1 under the curve f prime of x dx. And you might say, but wait, I don't know what the graph of f prime of x looks like. Yes, you do. We knew from earlier that f prime and g are the same thing. So all I need to do is find the area bounded by the graph of f prime from -5 to 1 and the x-axis. So here's -5. Here's +1. I need to find that area. I see that I'm going to have some negative area. We're below the x-axis. And I see that I have some positive area above the x-axis. So let's put this all together. F of 1 is 3 minus the area from -5 to 1. Well, what do I see here? I see a trapezoid, and the area of a trapezoid is 1/2 the sum of the bases. Here's the first base. Here's the second base. Those bases have to be parallel to one another. The first base has a length of 3. The second base has a length of 4. And then I'm going to multiply that by the height, 1, 2, 3. And keep in mind that that has to be a negative value because we're below the x-axis. Now I'm going to add on the area of this triangle over here. Area of a triangle is 1/2 base times height. So that's 1 times 2, 1/2, 1 times 2. You can simplify this if you want to, but there is absolutely no need for you to do that. For those of you that are curious about the simplification, 3 minus, let's see, 3 plus 4 is 7, times 3 is 21. 1/2 of that, I'm going to get -21 over 2, plus 1/2 times 1 times 2, well, that's 1. If I distribute the negative through, I get 3 plus 21 over 2 minus 1, getting a common denominator, that's going to be 25 over 2. I would hope that you would stop here. That's considered a safe stop. When all your values here are numbers, there's no need to go any further with the simplification. All you could do is possibly throw out a point that you just earned. I wouldn't want you to do that. They awarded points for setting up this integral here, the integral from 1 to -5 of f prime of x dx, and then 1 point for getting to the numerical answer, for a grand total of 2 points for part A. I would think that that's a pretty standard kind of question that most calculus students at this point in the course should feel pretty okay doing. Let's keep going. In part B, they ask us to evaluate the integral from 1 to 6 of g of x dx. That means they want me to find the area underneath the curve from 1 to 6. So from 1 to 6, g of x dx, g. We've got the graph of g. This time we want the area from 1 to 6. So let me get a different color. To find that area, well, let's see what's going to happen this time. Everything is above the x-axis, so we have positive area. That's good. I see this part over here. Well, that just looks like a square. I've got this shape here. That's not a triangle. That's going to be a little tricky. And this other part over here. The key to evaluating this integral, let me scoot my work up a little bit here, is going to be to actually look at this as two different integrals. If I want to find the area from 1 to 6, let me find the area from 1 to 3, and then add on the area from 3 to 6. And the reason why I'm going to break it up in this way is that the area from 1 to 3, well, that's just a square. I can find that easily enough. The base is 2, the height is 2, I get an area of 4, plus the integral from 3 to 6 of g of x. And they told me that g of x from 3 to 6 can be written as 2 times x minus 4 squared dx. Okay, we've made some progress. We went from one integral to two different integrals. The first integral we could evaluate using basic geometry. The second integral we're going to evaluate using our calculus techniques. So let's see, what can I do? The 2 is a constant. I can factor that out in front. I've got x minus 4 squared dx. Now, maybe you want to think about doing substitution. That's okay, and you could let u equal x minus 4. But since this is a linear expression, it's being squared, the antiderivative can be found just by adding 1 to the power, so x minus 4 cubed, and then dividing by 3. You've still got the 2 in front, and you've got the 4, and you've got to evaluate your antiderivative from 3 to 6. You'd get this exact same expression if you chose to do integration by substitution. I'm just going to get there a little bit faster. Okay, from here now you're going to evaluate, so it'll be 4 plus 2 times 6 minus 4 cubed over 3 minus 2 times 3 minus 4 cubed over 3. Again, it is perfectly acceptable to stop right here. You get all the points. If you want to go further and simplify, and I would not encourage you to do this, but let's do it. 6 minus 4 is 2. 2 cubed is 8 over 3 minus 2 times 3 minus 4 is negative 1. Negative 1 cubed is negative 1 over 3. We get 4 plus 16 over 3 plus 2 thirds. Well, that's really 4 plus 18 thirds. 18 thirds is really 6. 4 plus 6 is 10. They awarded 3 points for this problem. The first point comes in for knowing to write the integral as 2 separate integrals. Another point comes in when you successfully find the antiderivative of x minus 4 squared by substitution, by sort of guess and check. And then 1 point for the evaluation, which would come in right here, or for the simplifying. But again, look at how much work you had to do and how many maybe careless mistakes could creep in and what they would do is they would withhold this third point from you. So free response part of the exam, don't simplify, just get there and move on, and that gets you 3 points. All right, let's look at part C. In part C, for the interval -5 less than x less than 6, on what intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Well, what do we know? They want f to be increasing and concave up. Well, I don't have the graph of f. Oops, let me scoot that up. I don't have the graph of f in front of me. I have the graph of g. What I want to remember is that f prime is equal to g. Well, if f is increasing, then that means f prime, which is g, has to be positive. And f prime, which is g, is, if f is concave up, then f prime is increasing. So I'm looking at the graph of g and asking where on the interval -5 to 6 is the graph of g positive above the x-axis and at the same time increasing. If I look carefully at the graph, I'm below the x-axis over here. I'm on the x-axis from -1 to 0, and I don't start being above the x-axis until I get to 0. From 0 until, what is that, 1, I can see that my graph of g is positive and increasing. So I'm going to say from 0 to 1. I'm not going to include the 0, and I'm also not going to include the 1. So open parentheses on both. Is there any other place where g is positive and increasing? Well, that's going to be also on this interval from 4 to 6. Yep. They awarded 1 point for the intervals. They awarded 1 point for the justification for a grand total of 2 points. Again, I would hope that this would be a pretty standard question that would make us all feel pretty good. Let's finish it off with part D. In part D, we're asked to find the x-coordinate for each point of inflection of the graph of f. All right. So if f has a POI, a point of inflection, that means that f changes from concave up to concave down, or from concave down to concave up. That's the behavior of f. But again, we don't have f in front of us. What we have is g, which is f prime. So f prime, which is g, would have to make a change, so triangle for change, from increasing to decreasing, or f prime changes from decreasing to increasing. Again, I look at my graph of g. Where does g change from increasing to decreasing? I'm horizontal, I'm increasing, I'm horizontal, I'm increasing some more, I'm horizontal. I don't actually start to decrease until 3. But the problem with 3, and I think this is a tricky one. At x equals 3, I'm not making a change from increasing to decreasing or decreasing to increasing. At 3, I'm going from horizontal to decreasing. So let's keep going. Not at x equals 3, but right over here at x equals 4, the graph of g changed from decreasing to increasing. That happens at x equals 4. The graph of g actually never changes from increasing to decreasing on the interval that we're interested in. So our final answer is going to be x equals 4. And how did they award points? They awarded a point for x equals 4, and then they awarded the point for the justification. This one's definitely a little tricky because that x equals 3 is going to be a place where, honestly, if I was taking the test, I'd have to stop and think, did my graph G change from increasing to decreasing right at this point? No, it actually didn't. It went from being horizontal to decreasing. That's why it doesn't count as having a point of inflection there. But at x equals 4, my graph did change from decreasing to increasing. Part D is worth a total of 2 points. So that was 2 points on part A, 3 points for part B, 2 points for part C, and 2 points for part D for a total of 9 points. Hope that went well, and hope you learned a lot. Bye. All right, here we go. We were looking at the 2018 AB free response, question number 4. That means that since it's question number 4, that this is calculator inactive. So here we go. It's a long one. The height of a tree at time t is given by a twice differentiable function h. I'm not even sure if that's going to be important, but usually if the college board tells you something like that, it's going to be important. So I'm going to underline it. Where h is measured in meters, so we've got units, and t is measured in years. Okay? Selected values of h of t are given in the table above. Okay. So h is twice differentiable, h is measured in meters, t is measured in years, and we've got some data points, okay? In part A, we're asked to use the data in the table to estimate h prime of 6. Using correct units, explain the meaning of h prime of 6 in the context of this problem. Okay. H prime of 6, what do I know? I know that they're asking me to find the derivative of the function h at time 6. And so if I had a function, if I had an equation for h, I could find its derivative and evaluate at 6. Well, I don't have that. What I have is I have different points on the graph of h. And a common thing that we do in AP Calc, and I would expect it's going to show up on your free response exam as well, is that you're asked to approximate or to estimate the value of the derivative, slope of the tangent line at one point, and what you're going to have to do is use two other points on the curve that are close to 6 that you're going to use to find the slope of the secant line. So if I look at my table of values, I have t equals 5 and t equals 7, and I have the corresponding heights. So the derivative of h at 6 is approximately what I get by looking at the slope of the secant line that connects the 2 points. So this is slope of tangent. We're approximating with slope of secant. H of 7 is 11, H of 5 is 6, over 7 minus 5 is 2, we get 5 over 2. That's our approximate, or our approximation for the value of the derivative at time t equals 6. What does it mean? I would say at t equals 6 years, well, what does h measure? H is the height of the tree. So h prime is, at t equals 6 years, the height of the tree. Be specific. What's the height of the tree doing? The derivative is 5 over 2, which is positive. The height of the tree is increasing at a rate of 5 over 2. Now get me the units. What are the units in the numerator? Meters. What are the units in the denominator? Years. At t equals 6 years, the height of the tree is increasing at a rate of 5 over 2 meters per year. Gotcha. Perfect. Okay, so the College Board awarded 1 point for your estimate and 1 point for your interpretation, which had to include the appropriate units. So that is going to be 2 points for part A. Pretty typical question for the College Board to ask. Let's look at part B. In part B, explain why there must be at least one time t for the time interval 2 less than t less than 10 such that h prime of t is equal to 2. Why does it have to be true that h prime of t equals 2 for some point on the interval 2 less than t less than 10? Well, great question. And here's where you need to stop and think about the kind of question or the format of the question. They're asking you to show that the derivative has to have a particular value at some time on a given interval. That is a very typical setup for the mean value theorem. That is what the mean value theorem tells us if certain conditions have been met. The conditions that we need in order to use the mean value theorem, we need h to be differentiable on some open interval AB, and h to be continuous on the closed interval AB. And if we have both of those things, then what we know is that h prime is equal to h of b minus h of a over b minus a at some point on this interval. We won't necessarily know where the derivative has this particular value, but that it must have this value. Okay, so what we're looking for is for this guy here, this slope of secant line, to be equal to 2. What we're going to have to do is we're going to have to look at our table of values to see if the slope of the secant line is equal to 2 anywhere. Now, normally where I would start, because they said on the time interval 2 to 10, I would say something like h is twice differentiable on the interval, what was the time? Twice differentiable function h. H is twice differentiable, which means that h prime is differentiable and continuous. You can only be twice differentiable if you are differentiable, and then you also have to be continuous if you're differentiable, which implies that MVT applies. That has to be true. Great, now we've got to find the just right interval so that the slope is 2. We're going to have to look at the table of values, and let's see. If I go with the big interval from 2 to 10, 15 minus 1.5 is 13.5, divided by 10 minus 2, well, 13.5 divided by 8, that's not 2. Let's try small intervals. What about from 2 to 3? 2 minus 1.5 is 0.5. 3 minus 2 is 1. 0.5 divided by 1 is not 2. 6 minus 2 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. That's the interval. So the way I would write that is I would say h of 5 minus h of 3 divided by 5 minus 3 is equal to 6 minus 2 over 2, which equals 2. Therefore, by the MVT, h prime of t equals 2 at least once on the interval 3, 5. The interval 3, 5 is inside the interval 2, 10, so I've done what you asked me to do. The way they awarded the points, they said 1 point for finding the slope, h5 minus h of 3 over 5 minus 3, and then your conclusion using the mean value theorem. Now, I'm pretty sure that if you didn't stop to indicate that the conditions for the MVT have been met, that you wouldn't be awarded the point. That's pretty typical with the College Board. If you want to use one of these named theorems, you have to make sure that the conditions have been met. So that's part B. Let's look at part C. In part C, it says use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree, on the time interval 2 to 10. So average height of tree on the interval 2 to 10. Well, one of the calculus things that you need to know is that the average value of a function can be found by calculating 1 over b minus a, the integral from a to b f of x dx. So for this particular problem, the average height of the tree on the interval 2 to 10, we're going to need to find the value of 1 over 10 minus 2, the integral from 2 to 10 h of t dt. H is not a function that they've given to us, so I also don't have a calculator, so I can't put this in my calculator. I can't actually do the calculus. What I need to do is read the question again, where they say using a trapezoidal sum. Remember, a trapezoid is going to look something like that. You have 2 bases. You have a height. The bases are parallel to each other. The height is perpendicular to the 2. The area is found by 1/2 the sum of the bases times the height. If I were to plot these points, 2, 1.5, 3, 2, and let's actually do that. 2, 1.5, 3, 2, 5, 6, 7, 11, 10, 15, not drawn to scale, I know. I'm going to approximate the area from 2 to 10 using these intervals that they gave us. I'm going to make my trapezoids. Here's trapezoid 1, 2, 3, 4. Again, not drawn to scale. For each of these trapezoids, I need to find the area. These sides here are your bases, so the length of each base is going to be determined by the y value. The height, the distance between those, is going to be the difference in the x values. So I've got 1 over 8. The integral from 2 to 10 is going to be 1/2. I need the height at t equals 2, which is, I've covered that up. Let me move that a little bit. Sorry. 1.5 plus the height at time 3, which is 2, times the distance between those two, which is 1, plus 1/2. We move on to the next interval. The height at 3 is 2, plus the height at 5 is 6, times the distance between those two, which is 2, plus 1/2. The next interval is from 5 to 7. The height at time 5 plus the height at time 7 times the distance between those two, plus the last one, 1/2, 11, plus 15 times 3. What is that equal to? I don't know. Clearly we could figure it out, but the fact is it doesn't matter. According to the College Board, if you work this out, you're going to get 263 over 32. What that is just a place where you are potentially going to lose points. So be careful. If this is the average height of the tree, you need units. So this is going to be meters. So the average height of the tree, which is what we're calculating here, 1 over 10 minus 2, the integral from 2 to 10 of h of t dt, is approximately 263 over 32 meters. Done. They awarded 1 point for everything that's in the brackets here. This is your trapezoidal approximation. 1 point for coming up with your approximation. There's no mention in the answer key of units, so I think even if you forgot to put the meters, you'd probably still earn the points, but why risk it? Put them in if you can. All right, last one, part D. Part D of this question. When I first solved this problem, it wasn't until the very end that I realized I had made a mistake and misread some of the information. So let's look at part D again. The height of the tree in meters can also be modeled by the function g, where g of x equals 100x divided by x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to the model, what is the rate of change of the height of the tree, rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? I realize I pretty much just went through and underlined every single part of this question. So let's tear this apart. Part D, they've given us a new function, g of x equals 100x divided by 1 plus x, where x is the diameter of the base of the tree. Okay, so x measures the diameter of the base of the tree in meters when the tree is 50 meters tall, and here is my mistake. When the tree is 50 meters tall, that doesn't mean that x is equal to 50 meters. The height of the tree, g, this means that g is equal to 50. When I filmed this earlier, I made the mistake and said that x was equal to 50. So what I know is that when the tree is 50 meters tall, at that moment, The diameter of the base of the tree is increasing at a rate of 0.03 meters per year. X is the diameter of the base, and the diameter of the base is increasing at a rate of 0.03 meters per year. So that's dx dt is 0.03 meters per year when g is equal to 50 meters. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So what they're looking for is dg dt when big G equals 50. All right, so I want dg dt, the derivative of g with respect to t, when g is equal to 50. They've given me an equation for g. G is 100x divided by 1 plus x. I can find the derivative, but I need to find the derivative with respect to t. This means that it's a rate of change question. And so we're going to have to proceed very carefully, much more carefully than I did the first time. So here we go. I want dg dt, the derivative of g with respect to t. But I see that I have x as my variable. Well, dg dt, we're going to use the quotient rule, which is low 1 plus x times the derivative of the numerator. The derivative of 100x is 100 dx dt, right? Because we're taking the derivative with respect to time, and the derivative of 100 times x is 100 times dx dt. Minus, let's see, we did low d high, minus high 100x times the derivative of the denominator, which is going to be 1 dx dt, divided by 1 plus x squared. Low d high minus high d low, all over low low. Okay, good. We're doing well so far. Now I need to find the derivative of g with respect to t when g is equal to 50. The mistake I made earlier is I found the derivative of g with respect to t, but then everywhere I had an x, I replaced x with 50, but that was the mistake because g is equal to 50. I need to know what the x value is. So I need to do a little side work here. I know that g is equal to 50. So given the equation they gave me, that means that 50 equals 100x divided by 1 plus x, and I need to find the right value of x that makes this true. I can do a little bit of algebra here. I can multiply both sides by 1 plus x. That gives me 50 times 1 plus x on the left. On the right, the 1 plus x and the 1 plus x cancel out, and that leaves me 100x. Distributing the 50, we get 50 plus 100x equals 100x. Subtracting 50x from both sides, we get 50 equals 50x. And so that means that x has to be equal to 1. So when you want to know about when the height is equal to 50, that means that the diameter of the base is equal to 1. So if I want to know what is dg dt when the height of the tree is equal to 50 meters, everywhere I have an x, I'm going to replace 1. So we're going to get 1 plus 1, which is 2, times 100. dx dt at the time when the height of the tree is 50 meters is 0.03 minus 100, times x is equal to 1, times dx dt 0.03. Bad spacing there, sorry. Divided by 1 plus 1 squared. Simplify this if you want to, you don't have to. 2 times 100 is 200, times 0.03 is going to be 6. 100 times 1 is 100, times 0.03 is 3. 1 plus 1 is 2, 2 squared is 4. We get 3 over 4. And if I look carefully at the question that they asked, what did they ask?
According to the model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So if you want to wrap this up and explain it in a sentence, what I would say is when the tree is 50 meters tall, the height of the tree is, let's see, this is a positive rate, so we're going to say is increasing at a rate of 3/4. What are the units? The units for the height, height is being measured in meters. The units for time is years. So this is being measured in meters per year. The way that they awarded the points, there are 2 points for coming up with an expression for dg/dt. And then there was 1 point for coming up with the answer, which I would argue you get to the answer when you have 3/4 as your final answer. There was nothing that specified that you then needed to write the final answer in a complete sentence or including the units. So this is worth 3 points. And this is the fully correct answer to this problem. Hope that helps.
All right, so here we are on the final slide. Let's talk about support beyond this session and what that looks like. First and foremost, go to the source. If you want more support, then go to the College Board website. This is the tiny URL. I thought it would be a little bit easier for you to type this in on your computer. But the College Board is going to continue to push out videos, practice problems. Since they are the ones designing the exam, this is absolutely the best source for you to go to for problems and support. If you liked the videos that I created, if you thought that was helpful, hearing me sort of narrate through the problem and annotate the problem as I would as though I was in class with my students, then feel free to go to my YouTube channel. You will find, I think, 50 or 60 free response questions that I've worked out in that same way, plus about 100 videos. There's probably 1 or 2 videos for each major concept on the calculus exam. So spend as much time there as you would like. If you have occasional questions, if you want to take a screenshot of the problem and your work and send it to me, that's fine. My email address is keith.derosier@yesprep.org. Make sure you spell that correctly. keith.desrosiers@yesprep.org. And then finally, there are office hours being offered on Saturday, April 18th of 2020. I'm still not sure when the start and stop times are for the office hours, but you are all more than welcome to come on by, and I'm sure that Rice University will be pushing out more information to you all soon. I hope you found this to be a helpful session. I know I really enjoyed pulling everything together. I regret that we didn't get to meet each other in person. I would have designed the session a little bit differently, but really do wish you all the best on your exams this year. Bye.